VAERS is the vaccine adverse event reporting system, and I, in fact, have been examining this data for many years now. And it is a government database owned by the FDA and the CDC and HHS, and it's designed to detect safety signals that weren't found in pre-market testing. And when these safety signals are emitted by the system in the form of a lot of data points, let's say, a necessary assessment must be done in the way of causality assessments or proportional reporting ratio assessments. Now, if we pull out the VAERS reports of cancer as of October 6th, it looks like this per 100,000 doses, according to the CDC age grouping here. Now, 13.7% of these people were also reported to have died, and this is skewed toward the right, which are the older people in the cohort, which isn't surprising. And out of interest, the top 10 reported cancers are on the left here. But what you won't see are the rare cancer reports, which include male breast cancers and acute lymphocytic leukemia, which is a childhood leukemia, for which the average age of the reportee is 50. Another point of interest here is that if you look at the cancer reports for all vaccines combined in VAERS for the 3 years before the COVID rollout and 3 years after, and only look at the cancer reports for the COVID-19 products, you get a chart that looks like this when you compare them per 100,000 adverse event total. So something very different is going on in terms of the COVID-19 products. And apparently there's an increase in reports when you compare them per 100,000 adverse events. We've published a preprint which examines the DNA contamination issue, we being me and Kevin McKernan et al. And as part of this report, we looked at forming a dose response curve. And this is really important because the Bradford Hill criteria are actually the criteria that you use to do a causality assessment. So if you want to determine if a drug is causing an adverse event, you can go through the Bradford Hill criteria, of which there are 10, and should satisfy at least 5 or 6. So one of these is dose response. And what that basically means is that if you have greater exposure of a drug, do you have greater incidence of, say, serious adverse events, for example? And in the case of our paper, what we did was we looked at higher DNA content as measured in the vials per serious adverse event report over total adverse events. So this is just the beginning of what looks like a dose response curve. And yes, we are testing more vials, and yes, we are gathering more data. And yes, we are anticipating that this dose response curve will actually be a dose response curve, i.e., the more DNA contamination you have, the more serious adverse events you have. But that remains to be seen. We need more data. And on the right, I've put together the number of cancer reports per 100,000 AEs per dose in VAERS, and I went all the way up to dose 5. And it certainly does look like there's the beginning of another type of dose response curve here as well. Certainly, it is obvious that as the dose number goes up, the number of cancer reports per total or per 100,000 adverse events also goes up.